Hi guys, welcome to my video on containerization. So as part of this video, I'll give you an introduction about what exactly container is and why it is so different from the container world and why these days people started talking about containers, Docker, then we have Kubernetes, Rocket, why those are getting popular and what are the benefit it gives out of it. So let's begin. So very first thing I'll try to explain you about is what exactly containers are. So consider an old system where what we used to do is we used to write code in our local machine, then we used to test it totally in our local machine, then we push the code to Git repository. From there it will be pulled to some environment. It will be built into application and pulled into some dev environment or QA environment or production environment. So there was a little bit of difference in environment from local machine, which might be a Windows machine. Then it is getting moved to some other machine, which is a Linux machine, and another flavor of Linux machine. So like that, the environment was keep on changing. But we tested our code only in particular environment. But as most of the languages like Java is portable over different kind of operating system also, but still we have little bit of gaps also. We'll have some environment specific configuration which might be missing, or some kind of updates which are missing from one latest Java to different version of the Java. So there the problem comes in picture. So our code is not tested in specific environment but tested in our local environment. So that's where containers or images or Docker comes in picture, where things are getting tested into the same environment where it is getting coded. So like in the image or in the container, we do a complete packaging of things like this is the environment, this is the environment, this is the environment runtime, and these are the dependencies. So everything is getting clubbed together into a single unit that is called an image, and out of image we create a containers. Runtime executable of images are called as containers. So that is what container is. As I told, we have a code, we have a runtime environment, we have a system tools, library, and environment setting. Everything we are clubbing together into a single unit that is called an image. So we don't have many problems like environment specific problems, and we are creating a easily portable code out of it which can be executed anywhere. So that is what container is. So let's try to compare that non-container environment versus containers environment. So what was the non-container environment about? So it was kind of one big hypervisor. So hypervisor is a service or is a kind of operating system which provides you another smaller operating system. Like consider it like a cloud service where you go and make a request for I want a machine of 4 GB RAM or 100 gigs of hard disk. Then it will give you it will slice it out of its available space and give it to you. So that is what hypervisor is. So hypervisor, so before system used to be created by using hypervisor, where we have some requirement like I want to create a dev environment, then I'll make a request to hypervisor or hypervisor admin to create a new machine out of it and give me a machine of 4 gigs RAM or 16 gigs RAM. So this was a big machine. Out of it, it was giving us a small VM out of it. So VMs are completely an independent operating system. Over that, again, we have to apply our software patches, application dependency, configuration for specific environment, everything we used to do. And then finally comes in picture the application. Whatever the code we wrote will get deployed into that particular VM. So this was the architecture of a bigger hypervisor or non-containerized application. Now when containers came in picture, so what happened after that? So containers. So here also we have a bigger operating system like the physical system of hypervisor. We have again same kind of architecture here also. But what is the difference is, instead of creating a new VM out of it, which is a VM is a heavyweight process, instead of creating that heavyweight process, what we are creating is a container, small container, like you can see in the picture. So the container is self-sufficient to run any kind of application, or we are giving it only that much kind of skills which is required to run our code. We are not giving it a complete operating system capability. We are not giving it a bigger space, but only things which it needs. So we are creating a small containers out of it. So these are the containers which are running inside a single operating system. So that is the benefit we can compare, right? Instead of creating a bigger VMs, we are just creating a small container. So that is a big benefit we are getting out of a containerization. And also this complete operating system cannot be a single machine. In the container architecture, this is not compulsory that you should have a single machine where you need to run all this. Instead of, you can create a clusters where if you want a container A to be executed, it will go into a separate node and there it will be executed. So this is container and non-container wise comparison. After that, let's try to understand it from 10,000 feet. So what are the things we had and how we will try to solve the picture. So we have many tools for solving this kind of problem, like configuration management or complete orchestration. We have Ansible is there, we have Chef is there, then we have Docker is there. But again, as I told in the previous discussion, like separate VM versus separate container. So if you go with Ansible or Chef, it will help you to create a separate VM kind of architecture, but Docker will help you to create a container wise architecture. Let's consider we have a requirement with the below requirement, like we want a machine with Java, Maven, Tomcat, Splunk, SSL configured. All these things we need to be configured inside a machine. Then after that, we have a next requirement, which is like to deploy our code. So whatever the application code, we have to deploy it. Then we have a next requirement, like to scale it, to create a 10 or 10,000 similar kind of machine to make a scalable application. Then these things are done by using Chef, Ansible, Docker and Kubernetes. So if all these kind of solution were capable of handling this kind of thing. But if you go with Chef and Ansible, it is concentrated on VM wise. So you can create that VM or you can configure that VM. But Docker, you can club it already an image, and just deployment phase will be the only thing which you need to do. And again, the Kubernetes is basically it uses some images and it deploys into that architecture. So as part of this video, I'm not explaining about Kubernetes, but that is also a very good orchestration tool, which might be in next video I'll try to explain. So let's try to understand more about container. So containers or virtualization, how it is done. So we have a code with us. We need a runtime environment like operating system, Ubuntu machine or Windows machine. That was the runtime for us. Then we have an environment specific requirement, like we have need Java to be installed or Maven to be installed or some port to be opened. Those needs to be done. So this all these things we are clubbing it together into a single spec definition, and that is all together is called a Docker image. So we are defining all this combination of runtime, code, environment, and any other build deployment details inside that spec, and that is called as Docker image. Now this Docker image is completely a read-only entity. We cannot create, we cannot use it directly like a VM, but out of images we have to create containers. Containers are actually a runtime entity of a image. So we can create a number of containers out of it. Containerization benefit. So what are the benefit we are getting out of it? So very first benefit, we don't have to deal with environment specific problem. Whatever we tested in local, we are sure about that will work in any other environment. So that no environment specific problem, we will not face it. we have code and environment, both are tested. Anything which is like dev or QA, it is already tested, that is properly working. Then what is the next benefit is, like we are running currently into this cluster, we can move it easily to another cluster without any configuration or setup change, and it is very portable runtime entity. So that is also one benefit. And isolation level, which is one more benefit Docker gives, that is I'll talk in some other session, not right now. Okay, so this is all about containerization benefits and what containers is giving us. After that, if you go into Docker, so Docker is a tool. Docker is a tool that gives you all these capabilities. Docker gives you containerization, Docker engine, where you can create containers and manage them. So that is what Docker is. So in Docker, we have containers again. So before containers, images, as I told, images like the definition, where you will have all the definition written in a spec file, and by using that image definition we create executable, those are called containers. So Docker image, so this is a prototype where we defined everything, like what is the base image it should be. It should like Linux is the base image, or I want some Windows as the base image. So it will take that base image, over that it will apply different layers of things. Like over Linux image, I want Java to be installed, that will be the next layer. After that, I want some more environment specific configuration, that will be appended to one more layer. So this is kind of layered wise architecture. And finally, I want the code to be running in some port or something, again one more layer will be applied. So this is the Docker image definition. So everything is built by using layer kind of architecture, and that will be divided into chunks. All layers will be divided into chunks. So this is Docker image. From Docker image, one more very important point about Docker images, this is just a read only copy. There is nothing which you can change after the image is created. Only the manager or who has created can change it. So read only copy. After that, Docker image, Docker containers comes in picture. So we created a read only copy. Now over that we can apply one more layer, which is a writable layer. So copy on write is one of the feature. What is copy on write is, Docker, when you create Docker containers, so over the Docker image read only layer, it applies one more layer, writable layer. And whenever you make changes to the environment, like if you are making one more file changes or appending one more file over that one, it will copy that file into writable layer and it will apply that changes only to that writable layer. It will not touch any read only layer. It will add or append or delete, everything is done over the writable layer. So this is container. So out of one image you can create n number of containers with a different name. Like out of Java code or Java class, you can create n number of runnable instance of that one. So in the same way, Docker containers are runtime entity or runtime instance of a Docker image. So that is all together Docker image and Docker containers. So this is all about this current video. I'll give you more details, and about next we'll try to create one Spring Boot application directly by using containers, and how to create images container out of it. Thank you guys for viewing this video.